Hey guys, chapter 14, 6 reaction mechanisms is what we're talking about right now, and so here we go. Reaction mechanisms is the process by which the reaction occurs. Reactions may occur all at once or through several little steps. And the reaction mechanism, each of these processes is known as an elementary reaction or an elementary process. So think elementary, think simple. Okay? Here is a chart of reaction mechanisms and their rate laws. Okay, so notice over here it says molecularity. The molecularity of a process tells how many molecules are involved in the process, and when we're talking about involved, we're talking only about reactants. See all these products? Rates don't talk about the products, they talk about the reactants. So in this case, there's one, so it's unimolecular. In this case, there's two, so it's bimolecular. In this case, there's also two, it's two different ones, but it's still bimolecular. And then there's 3, 3, and 3, and those are termolecular. Okay? Let's see if I can get my PowerPoint working here. Okay. In a multi-step process, one of these steps will be slower than all the others. And they are showing you the overall reaction rate cannot occur faster than the slowest step. That's the rate determining step. So that theme, like we're only as strong as our weakest link, well, this is only as fast as the slowest step. So in this case, you've got, this is like a toll booth, okay, you know, where you pay money to drive on the road. And this is Plaza A, and this is Plaza B, and look at all these cars jammed up here. You can't get any faster than the rate that they can go through Plaza A, okay? Now over here, they're cruising through Plaza A, but then they get jammed up at Plaza B. So in this first case, this is the slow step. He's going to determine the rate. In this second case, this is the slow step, and it's going to determine the rate. Okay? Oh, I know, because this is in the way. Okay. So, sample exercise. Determine molecularity and identifying intermediates. Describe the molecularity of each elementary reaction in this mechanism and write an equation for the overall reaction and identify the intermediates. Okay, so it's been proposed that the conversion of ozone proceeds in a two-step mechanism. First of all, we need to describe the molecularity of each. Well, this guy, only has one reactant. So for the first reaction, we would say this is unimolecular. Okay? This one has two reactants, so we would say this one is bimolecular. All right? Now, it says write the overall equation for the reaction and identify the intermediates. Intermediates are anything that are there and then go away. So the overall reaction for this is just add everything together on the reactant side and on the product side. So on the reactant side, we have O3 gas plus O2 gas. And on the product side, we have O2 gas plus O. Oops, this shouldn't be O2. O3, and this should be just O. And we have O2 gas, and we have O gas over here. Okay? So intermediates are things that are present on both sides. Well, this is present on both sides, so this is an intermediate. So the actual overall reaction for this is O3 gas yields O2 gas. Okay? And